Hello everyone. In this video, I'm going to talk about compound events. What are compound events? First of all, we need to know that compound events are the events which is a combination of group of individual events, and you try to find the probability of those individual events and create your different possible sample spaces. So if you're looking at a probability going um, from left to right. So in the probability tree diagram, we are going to calculate what is the probability of first event followed by the second event together. So I will show you what to do. And then this is called your sample space. So what are all the possible sample space um, that can be created or generated using your two independent events. So let's read this story. So I will explain all the vocabulary details, bits and pieces, but let's try to understand here. This is without replacement. So that is a very important keyword. That means you're not replacing it back into the bag. So Maya and Jack are on a math quest. They find a mysterious bag with 2 red balls and 3 blue balls. Maya picks a ball at random, puts it aside, and then picks a second ball without replacement. What could happen? Let's map all the possible outcomes. So, without replacement means you need to understand that the total amount in the bag is reducing. So that means, as we know, in a probability, we always write out of total possible outcomes. So you need to know the total is decreasing. And also, if one of the ball, which is red, has been pulled out, then you also have to subtract that color ball has been now reduced as well. So not only the total, but also the first object that came out of the bag. So these are the two important scenarios that you need to keep in mind. So as of here, on here, this is a tree diagram, and we are going to do probability tree diagram because we are going to also indicate the probability at the end. Now these are called sample spaces. So whatever combinations you are getting that you're writing at the end, those are called your sample spaces. But if you are trying to see so first red, second red, that is like red and red. So that becomes a probability tree diagram. So if you're trying to find the probability along this tree diagram, you have to multiply. But if you're going to add the sample spaces, you're trying to find what is the chance of getting either like two same color or two different colors. That is like you're looking in the sample space and you're trying to pick those samples and you're going to add them. So one is multiply. So if you're going from left to right along the tree, you're going to multiply. But if you're going to look and look your sample spaces, which is this vertical way of looking, then you're going to add them. So those are the two key things that I want you to learn in computation wise. So let's begin. So you are having 2 red, 3 blue. So in the first draw, what could happen? So you can pick a red ball, so that would be 2 out of 5, or you could have picked a blue, which is 3 out of 5. So 2 out of 5 and 3 out of 5 here, you will write that. Now you will draw second time. You have an option to draw second time. Now the total has gone down. So instead of 5, because 1 is already removed, 1 has been removed. So you're going to do 5 minus 1. That's why you're getting 4. But if it was a red, so that means the red has gone down as well. So now you only have 1 red in the bag. So 1 out of 4. Now if the second draw was a blue, the total is still down by 4, but you still have 3 blue balls in the bag. So this should have been 3 out of 4. Okay, and then, so what is the chance of getting the first red and the second red? You would multiply 2 out of 5 times 1 out of 4. And that would end up as 2 out of 20. Now getting the first red and then blue, you would multiply whatever is on this branch. So 2 over 5 times 3 over 4, which is 6 out of 20. Now let's say if my first ball was blue. So then what happens? My second ball, you still have 2 red inside the bag. So you would have done 2 out of 4 because one ball has been subtracted. Okay, so the total is still 4 here in the second draw. So then here, but if first one was blue, then you should have done 3 minus 1 blue, which is 2 balls remaining out of 4. So this is still blue, red, this would be blue, blue. And then if you're going across left to right, I said multiply those fractions on the branches to get the probability outcome. But let's say the question says, what is the chance of getting two balls of same color? Two balls of same color, they didn't specify that it has to be only red, red, right? So it can be red, red or blue, blue. They both are same color in both draws. So then you would do 2 over 20, right? Plus 6 over 20. And that would be, so 2 over 20 plus 6 over 20, which is 8 out of 20, which is nothing but 2 out of 5, which is nothing but what is the chance? This is going to be 0.40 or 40% chance. So you have a 40% chance of getting same colors. You see how you may think that means there are only 4 sample spaces, which is red, red, RB, BR, BB, and you would by default in your mind you would think that they all have like 25% chance, but in this case no. So you have only 40% chance of getting um, uh, the same color balls in both draws. Okay, so that means having a different color, the red blue or blue red, should end up being 60% because the total should always add up to 100%. So when you look at all the fractions and you add them, make sure that it equals to 1. 1 represents 100% in our probability world. So that's the trick with replacements. All right. So hope you have enjoyed this video. Check out the other videos for more examples. Have a wonderful, blessed day, guys. Bye-bye.